Hello everyone, this is Rong. I'm about to give a presentation for the class Image Processing and Computer Vision. My topic for the project is improving hybrid image performance through suitable filters. First, let's run this MATLAB program because it will cost some time. Okay. This presentation will contain 4 main topics. First is the background knowledge of hybrid images. Second is the approaches to realize hybrid images. And the third part is performance evaluation. I did some experiments on my own to produce some hybrid images. And this is where I will discuss my experiment results. And the last part is called conclusion. Now, let's look at some interesting photos here. When you look at the pictures at a relatively close distance, you will be able to observe a children's bicycle here. It's very clear, right? And also the picture of Albert Einstein. However, if you stand at a few steps back now and then look at these pictures again, they will become a picture of a motorcycle and Marilyn Monroe. Here's the same thing. When you look at these pictures closely, you will see a cat face and a house which is being constructed. And when you look at it at a further distance, you will only see a woman's face and a new house which has been constructed already. This PowerPoint slides illustrates several famous pieces of double image artwork. Each piece can be interpreted differently depending on the distance of viewing or the size of these pictures. So, what is hybrid image? Hybrid images are static pictures with two interpretations that change depending on the image's viewing distance or size. The phenomenon of hybrid images arises from the multi-scale processing of images in the human visual system. The phenomenon More precisely, a hybrid image is a single picture that combines the low spatial frequencies of one image with the high spatial frequencies of another image, producing a new image with an interpretation that changes with viewing distance or size. Here, let's look at these pictures on the right. There are two hybrid faces. The fine spatial scale represents a non-expressive woman in the bottom image and an angry man in the top image. Yeah, he's very angry. And the coarse spatial scale represents the angry man in the bottom picture and the neutral woman in the top picture. If you want to see this low spatial frequency faces, you can either squint, blink, or step back from the picture until your perception changes. This is very famous hybrid image here because the performance is quite well. So, how can we produce some hybrid images? Hybrid images are produced by superimposing a coarse image and a fine picture together. There are certain things to consider when creating a hybrid image. First is the rule of contrast sensitivity function for near and far viewing, and the perceptual grouping effects. Now let's talk about the role of the contrast sensitivity function for near and far viewing. It's quite complicated, but we will talk about just the easy part. So this is about it's well known that the human visual system sees the world through the contrast sensitivity function, which acts as a bandpass filter, effectively making low contrast information at particular spatial frequencies invisible to the naked eye. So, when we're producing hybrid images, we will have to consider the bandpass frequency of the filter in order to produce the best image. There, I represent a cartoon illustration of the type of information contained in the hybrid image. from any distance. The hybrid is a mixture of low spatial frequency and high spatial frequency components. Here, as I have shown in this chart, the low spatial frequency is in green of Sigmund Freud, and the high spatial frequency is in blue of the Albert Einstein. This chart here shows from a distance greater than 3 meters. The information visible to human observers is predominantly driven by the low spatial frequency components. So as a result, we could only preserve the Freud when we look at the picture, the hybrid picture at this distance. And this chart here shows from a distance inferior to 0.5 meters, when the high spatial frequency component will dominate the perception, so we should only see Einstein. And the other principle is called perceptual grouping effects. It's very complicated, and it includes a lot of things. But the most important thing about that relates to hybrid images is this. The most compelling hybrid stimuli are those where the shape and forms of the two original images are alien, permitting the mind to switch interpretations by reorganizing the visual information. Now, let's try to use MATLAB to produce hybrid image. According to the two principles we have discussed earlier, I choose two of my own images when I took at the same time, of one with a happy smiley face and the other with a frustrated sad face. These are, of course, very alien and have an identified contour, so I think it will be easier to use these two to make a hybrid image. There are three main steps of the program to produce hybrid images by using MATLAB. First is to write my own filter called Rong filter. And the second is to use Gaussian blur filter to remove the high frequencies from one image and remove the low frequencies from another image. The last step is to combine these two filtered images together to create the final hybrid image. Now, let's take a look at the codes. Here is the filter of my own. This filter is used as a function in the main program, and this program is used to adjust the original images in order to deal with the pixels near image edges, so that the function is able to process both color images and grayscale images, and could return a filtered image which is the same resolution as the input image. To make this function work, I padded the original image with black pixels around its edges according to the size of the filter, and then I applied the filter on each pixel, calculating different color channels separately to get the filtered image. And this is a function to save and represent the produced image. This is the main program. First is to read these two original images into floating point format, and then to set up the filter and hybrid image construction. According to my experimental results, the best result of this hybrid images I produced is to set the cutoff frequency as 15, so I choose 15 at this time. And here's the F special. This is provided by MATLAB, and use the Gaussian filter as the low-pass filter to pass through the frequencies and produce the low frequencies and high frequencies. The low frequencies is equals to the Rong filter of this result. Oh, okay, so we already have the results here. Now let's see. This is 1, the frequency equals 15. This is the low spatial frequency of the sad face of mine. Okay, it's very blurred. And this is the high spatial frequency of the smiley face. Okay. And this is the result of the hybrid images. We could see this is when we look at this photo, it's a big photo. It's a big picture on the screen, and it's a happy smiley face. But as the size of this image is getting smaller and smaller, what we could see is just my sad face. It worked. I think it worked quite well. And so where were we? The low frequency equals to the in filter of just filter this original image with the Gaussian blur filter. And however, the high frequencies will equals to its original image subtract the low frequency of the filtered image. And the hybrid image will equals to these two added together. When we apply this Gaussian filter to the two-dimensional image, the Gaussian filter will produce a surface whose contours are concentric circles with a Gaussian distribution from the center point. Values from this distribution are used to build a convolution matrix which is applied to the original image. Each pixel's new value is set to a weighted average of that pixel's neighborhood. The original pixel's value receives the highest weight, and neighboring pixels will receive smaller weights as their distance to the original pixels increases. Okay, here's so much about the program. And this is when I tried to set the cutoff frequency at 7, and because I want to produce the best hybrid image, so I wonder which will be best to use as the low spatial frequency. On the left is the low spatial frequency of happy face, and on the right is the low spatial frequency of sad face. As we could see, it's very clear that when we use the low spatial frequency of sad face, the hybrid image is much clearer than this one. So I choose to use the low spatial frequency of sad face in the following experiments. And through several experiments, I figured out that when I set the cutoff frequency at 15, we will have the best hybrid image. This is the low spatial frequency of sad face and the high spatial frequency of happy face, as we have shown, as I have shown of that program we just ran earlier. And here's different scales when the cutoff frequency equals 15. When we look at this, I think this picture best represents when we could see both of the sad face and the smiley face. When the image gets bigger and bigger, we could only see the happy face clearly, but when it gets smaller and smaller, what's left is just the sad face. Okay, now is the conclusion part. This project is focused on finding the most fitted filters to filter the original images in order to enhance the quality of hybrid images. As we could see from the experiment results, using different cutoff frequency to adjust the low-pass filter and the high-pass filter could lead us to very different results. In this project, the larger the cutoff frequency is, the clearer the high spatial frequency element is, and the more blur the low spatial frequency element is when people look at the hybrid image up close. And this project is a very nice try in image processing area. That's all. Thank you.